Hello there and happy Tuesday. Today we are going to take notes on the last form for our linear functions, and it's standard form. I think last week I kept saying standard form for slope-intercept form, and sometimes I get my words mixed up. But today we're going to talk about standard form. So you guys have learned, oops, I'm sorry, let me flip back. You guys have learned slope-intercept form, and that is the best form to get your equations in when you're graphing, because it tells you where to start and how to move. You guys have learned about, here it is, point slope form, which you're able to take a slope and a single point and rearrange it to get it into slope-intercept form. So we have an example down here where we used this point and the slope and we got it into slope-intercept form. And then we talked about special cases where you can get your slope-intercept form from 2 points from a table. So the 2 points you had to first originally find your slope using our slope formula, and then plug in the slope and a single point. You can get your formula. You can get your slope-intercept form. We also talked about how to get your slope-intercept form from a table, because again, you can use 2 points that are on that table and find your slope and plug in a slope and a point. And then we also talked about how you can find your slope-intercept form from a graph. So look at where does it cross the y-axis and how does it move. You guys have had a lot of practice with that. And the last form that we're going to talk about is standard form. Standard form is really good when you've got linear word problems and they're telling you, you've got this item, it costs this much and you have this many. And then you have another item, it costs this much and you have this many, and this is the total amount that you have. You can take that information, put it in a standard form, and if you need to, you can rearrange it as always to get it in slope-intercept form. Or you can use that form that you have it in standard form to solve for missing parts, as always, as we always do in math. So we're going to title this page Linear Functions Standard Form. Okay, everyone can see that? Perfect. The standard form looks like this. Okay, so in this formula here, or in this function ax plus by equals c, I want you to look at your a as item number 1 and b as your item number 2. So I'm going to give you a few word problems here below, and the item that they're talking about, that will be referred to as a, and another item that they might be talking about will be in place for b. So underneath, I want you to write really what this formula says. It means item 1's price, will go where A is, times how many there are, plus item 2's price times how many there are, equals the total cost. So if you were to break down what each one of these letters actually stands for, this stands for the first item's price and how many you have. So if it costs $2 and you buy 3 of them, it's 2 times 3, right? $2, 3 different times. That's what you purchased. Plus your second item, however much it cost and however many you bought, will be equal to the total amount, that you're given. So this is what I want you to think about when you see this. So I'm going to give you 3 problems today, and they will go in your notebook here as examples for you to refer back to. So the first one, you have $20. Again, as I always say, if at any point when we're doing our notes you need to pause the video because you write slower or you like to listen to me and then pause it and write it on your own, please pause whenever you need to. You have $20. Movie tickets are $5. Drinks are $2.50. Write in standard form. Okay, so when I look at this, I need to find two different items, their prices, how many, and a total. And that's how I need to separate all of my information. So item number one, what are the two items that you see in this word problem that they're talking about? I see movie tickets as an item, and I see drinks as an item. Those are the two items that I see, and the prices are going to come after that. So movie tickets are $5. Drinks are $2.50. So if it tells me up here how I need to write it, if I want movie tickets to be item one, I need to put item one's price first. That's going to be my A value. So what is item one's price? $5. And then I need to multiply it by X, or how many. I don't know. It didn't tell me how many tickets she bought. So we're just going to put X there. $5 for the movie tickets times however many movie tickets. That we don't know. Plus, B is item two. Do we see a second item here? Drinks. We see drinks. What is the price for those second items? $2.50. So I'm going to put $2.50 here, and it gets multiplied by how many? Does it tell us how many drinks are bought? It does not. So that's just going to stay as a Y. And then we have to set it equal to a total. Do you see a total amount of something here? I do. $20. If movie tickets are $5 and drinks are $2.50, I see a total of $20 that we have. So this is the standard equation for this word problem. $5 for movie tickets, and you can plug in however many you want to buy, and $2.50 for drinks, and you can plug in however many you want to buy, and it can't be more than $20. So let's say Sally wants to go to the movies. She has $20, and she now knows that movie tickets are $5 and drinks are $2.50. Using this equation, she can figure out how many tickets she can buy and how many drinks she can buy without going over $20. And so she can just plug them in. Or she can say, okay, if I buy 2 movie tickets and I put 2 here, how much money do I have left over to buy drinks? So you can use it for many different things. I'm going to give you another example here. Oops. You have $100. Pants are 15. Shirts are 10. Write in standard form. Okay, well, let's look at this. I should find 2 items, and I do. Pants will be item 1, shirts will be item 2. And I need to look at the dollar amount that goes with them. So I see that pants are $15. So that's going to be my first number, right? The price. How many pants? It doesn't say. So just leave your X there. Plus, the next dollar amount will be shirts. Those are $10. How many shirts? It doesn't say. So we just leave the letter. And we're going to set it equal to our total amount. We have $100. Ta-da! And so you can use this again to solve for X or solve for Y and figure out how many pants can you buy, how many shirts can you buy. So I could buy 10 shirts at $10 and no pants at all. And that would be $100. And so you can start to get points. If Y is 10, X is 0. You know? What if I wanted to buy 7 shirts? Well, 7 times 10 is $70. So how many pants can I buy if they're $15 a piece? So you can use these equations to help you solve them. So we're going to do that for this last one. So that is how we set them up from the word problems that are given, how we set them up in standard form. And now I'm going to show you how you actually solve using your standard equation. Jody has $50. Movie tickets cost $7.50 per ticket. And candy costs $2.50. Okay, so first let's just make our equation here. From the information that they gave us, I see two items, movie tickets and candy. So let's look at the price for those. So movie tickets is $7.50. That's going to be our A value. And then how many? It doesn't say as of yet. It just says that they're $7.50. We don't know how many she bought. And then we have to add the next item. I see candy. Candy is $2.50. And how much candy did she buy? We don't know. But we can set it equal to our total, which is $50. So this is the equation from this word problem. Now, what if it asked if she buys 5 tickets, how much candy can she get? Well, it gave us one of these variables. It didn't give us the other, but we know how to solve for a missing variable. We've done this since day one. So let's figure out what we need to plug into our equation. If she buys 5 tickets, okay, this is a number right here, 5. Where are we plugging 5 into? Okay, remember up top where we wrote A stands for the item's price, and then the X beside it is how many of that item you have. B stands for the other item's price, and then the Y stands for how many of that you have. So if we look at what we've been given, this is the price of the first item and how many. This is the price of the second item and how many. So if they are telling us that she bought 5 tickets, movie tickets is our first item at $7.50. So that's this one right here. $7.50 is talking about movie tickets. This is the price. This is how many. They just told us how many, 5 tickets. So we're going to plug 5 in right here for X because we now know how many tickets she bought for $7.50. And then we'll be able to figure out how much candy she can actually get if candy is $2.50 per piece. If this is her total, how much of this can she get if she's already bought 5 tickets? So we're going to plug 5 in. $7.50 times 5 plus $2.50 times Y equals 50. Okay, well, we're going to distribute this and use a calculator if you need to, because anything with decimals, it's hard to do that in our heads. It can be. So $7.50 times 5 is $37.50. I'm not going to put that 0 on the end of it, just 37.5. And bring everything else down. Plus $2.50Y, when we multiply those two, equals 50. Okay, so we're making progress. We're solving for Y. Y is the amount of candy she'll be able to get. We don't know that yet, and that's what we're solving for. That's what it asked us. How much candy can she get? That means if we're solving for Y, we have to get Y by itself. So this is just like any other multi-step equation at this point. We have a number completely hanging out by itself, and then we have a number attached to the Y. So what are we going to move first? This plain number. We always add or subtract first, and then we multiply or divide. So we are going to subtract this 37.5, move it over, that's gone. Now we have 250y equals 1250, or 12.5. And again, you can plug this into a calculator. 50 minus 37.5 gives you 12.5. So we have one last thing to do to get y completely by itself. You guys know this. We're going to divide away the 250 because it's being multiplied by 250. So to undo that multiplication, we have to divide. What you do to one side, you have to do to the other. And so now we have y completely by itself, and y is set equal to, when you plug this into the calculator, it's going to give you 5. So if she's bought 5 movie tickets for $7.50, that's $37.50. Well, if you subtract that from $50, which is her total, that leaves her $12.50. And if each piece of candy costs $2.50, what number can she multiply that by without going over, right? $2.50, she can get 5 pieces and not go over. And we found that out by solving for y and getting it completely by itself. So we basically undid this equation and figured out what y can be by itself. And you can do that the other way around too. So if they give you a word problem, you've created your equation, and they say, she's bought 15 pieces of candy. Does she have enough for movie tickets? And if she does, how many movie tickets can she buy? So you would have plugged in for the candy right here and been solving for x. So either way, you can do this. If they give you one part, you solve for the other. And that's how you solve using standard form. So I'm going to give you some word problems and have you write it in standard form and then solve for one of the parts for standard form. Make sure you get these notes copied down today and you get your practice done.